Hi everyone, we are Rayhan, Suraj, and Keshav, and this is PathGuard Edge. Over 800 workers die each year in construction, primarily from slips, trips, and falls. We realize you cannot solve this by streaming 4K bodycam footage to a cloud GPU. Job site lack the cell service and bandwidth. Spatial safety intelligence must live on the edge. As you can see in our architecture diagram, video flows in two parallel systems. On the left, we have Narrator runs Liquid AI's LFM 2.5 vision language model entirely on device. This high optimized 1.6 billion parameter model generates tra- scene transcripts and dynamic scene specific prompts. On the right, we have PathGuard HUD, which runs a real-time spatial reasoning pipeline, fusing classic computer vision, zero-shot detection, and depth estimation direction on the edge. Finally, on the bottom layer, bridges the two injecting PathGuard physical risk events into Cactus semantic telemetry report. Let's jump into the live demo. Here is the Cactus Narrator running the Liquid LFM 2.5 model entirely locally on Apple Neural Engine. It supports two inputs. Mode, video mode and live web. First, in real time mode, we can see how phone camera acting as a body cam notices how the on device VLM instantly starts generating transcript on what it's seeing on the real world. Acting It will generate a Dynamo prompt and RCP telemetry for the session history. Now let's move to the video file. We have taken a small portion of the video for only 16 seconds. As the worker walks, Cactus generates rich translation. Once the video finishes, point to the pointing that the video Cactus automatically summarizes the session. It extracts dynamic list of ground Dino prompts specifically tailored to this extract scene rather than relying on static hallucinated list. Over here we can see the primary scope, what it could be. Masonry construction as we have shown different footage. It categorizes what job scope are the people doing as well. Now for PathGuard HUD. But semantic understanding isn't enough. You need to know its hazard is actually in your physical walking path. We take those dynamic dyno prompts and feed them into the PathGuard HUD. Notice the yellow trapezoid on the screen. We call them the centroid ROI. It represents the worker's actual walking lane on the egocentric body cam direction, and all hazard reasoning happens strictly inside that region, while classical computer vision fall back layer runs on every frame. Grounding dyno runs on schedule to detect objects inside the cor- corridor using the text prompt we next generate. We also run SAM2 to refine those detections, bounding boxes into highly precise pixel mask. Simultaneously, depth and anything to V2 estimates relative distance, classifying obstacles as far, mid, or near. Based on the detection, segmentation, and depth data, we compute occupancy metric, the ratio of obstacle pixel inside the corridor of the total corridor area. Finally, how do we bring this all together? A safe tool is useless if the site manager doesn't get the data. When we shift over to PathGuard, bridges the gap. It takes the site's reports generated by the Cactus and injects the actual physical telemetry, peak corridor occupancy, depth bucket, and extract trip risk event timestamp. This isn't an AI sandbox, it's a scientifically rigorous, full integrated telemetry pipeline designed for real world edge deployment. Thank you.